Welcome to the course on welding health hazards and controls, air and surface contaminants. This is the first part of a three-part webinar series. This class is brought to you by the Kentucky Education and Labor Cabinet, Office of Occupational Safety and Health, as a service of the Division of Education and Training. My name is Jeffrey Kahn. I'm a retired industrial hygiene consultant with Kentucky OSH. However, I still conduct training through these KY Safe webinars. Okay, now let's get started with this. This series of webinars is only an overview for your awareness purposes. I have a limited amount of time to condense a huge amount of information for you. When I say you, I mean you all, which includes both employers and employees. It is not intended to overwhelm you, but just to let you know that you need to know what you are working with on your job, and that there are ways to protect yourself from those potential hazards. Time won't allow me to go into great detail about all aspects of each possible health hazard associated with welding. We have other online training classes about most of these hazards, one at a time. We also have week-long in-person conferences at our Pop Center training locations. Not all welders will work with, nor will they be exposed to everything that I will talk about today. Time won't allow me to list every possible metal fume, chemical byproduct, or other air contaminant that could occur while welding. This is just to let you know some of the main health hazards that could be out there in the workplace where welding is being done. Keep in mind that the poison is in the dose. That is how much of it that you breathe in and over what period of time that you are exposed. OSHA generally determines your exposure of air contaminants by attaching instruments to the worker during a full shift workday. These instruments provide real-time data about how much welding fumes and other air contaminants that you are exposed to on that day, which should be a typical workday. OSHA has established limits on the amount of air contaminants that an employee can be exposed to during a typical 8-hour workday. This is averaged out during that time span. Sometimes it can be higher, sometimes it can be lower, as long as the average value over that 8-hour time period remains below the PEL. These limits are called PEL, P-E-L, which stands for Permissible Exposure Limit. Also, OSHA has established midpoint limits on certain severe hazardous air contaminants. These limits are called action levels. They are usually 1/2 of the value of the exposure level set by the PEL. At the action level, some corrective actions are required and/or additional personal monitoring of air contaminants must be conducted. I will be referring to the OSHA PEL and the action levels throughout these classes. I want to at least let you know why these issues are important and why the control methods help protect you. The class objectives today. As I stated earlier, this is the first part of the three-part webinar series. We will discuss the occupations and work sites where welding is either part of the main part of the job, or it might only be a part of your job duties. Just to set the stage, we will quickly describe the welding process and the welding machines used to do it. We will mainly be covering possible health hazards from welding. Usually, the hazards people first think of with welding are safety hazards such as fire, burns, and electric shock. However, There can be several hazards that could affect the worker's health. These can vary widely from job to job. Not all welders are exposed to the same health hazards. The type of metals used during the welding process could present hazards. The materials surrounding or attached to the surfaces of the metals that are to be welded could present different health hazards. The amount of time spent welding certain materials and the amount of ventilation, along with other control methods, can help determine the dose of the exposure to the workers. Today, in Webinar 1, I will discuss the health hazards of air contaminants and surface contaminants. Air contaminants are usually created from the intense high heat used to melt the metals. I will spend a lot of time talking about these. I will tell you about how exposure to welding fumes and other air contaminants in welding areas can potentially affect your health. I will also talk about location considerations, such as confined spaces and other non-welding workers working nearby. I will tell you about the OSHA permissible exposure limits. I will tell you about ways to control the work site to reduce or minimize the exposure to these hazards. Other health hazards that I will discuss during Part 2 and Part 3 of this webinar series include radiation, light, noise, heat and cold, ergonomic, and biological. We will also discuss control methods as we go along at the end of each section that we covered during this series. How widespread are the occupations that involve full-time welding, part-time welding, and down to only occasional welding? Welders are everywhere. You can find them all over the place, including but not limited to the following industries: oil and gas production. Nationally, Kentucky ranks about 22nd in oil and gas production, and a fair amount of oil and gas industry jobs come from the welding industry. Pipe fitters and boiler makers could be subcontractors moving from one location to another, with different hazards at each location, and they might have a different contact person or employer at each location. Independent, self-employed welders may have these same problems as pipe fitters and boiler makers of varying hazards and employers at different locations. There's welding also occurring in welding shops and also occurring in metal fabricating plants, also at auto and appliance manufacturing plants, and at mill workers and sheet metal workers. There's welding also occurring at auto repair shops. That includes general auto repair and body repair shops. You'll find welding in machine shops. You'll find it at metal recycling and scrap yards. You'll find welding in other places, various places, such as concrete plants, in agriculture, and in construction, or at any work site where machinery is used and occasionally needs repair. Before we go into the type of welding machines, let me provide some background information. You're going to hear the word arc, A-R-C, in reference to both electricity and welding. What is an electric arc? Arcing is where an electrical current jumps a gap in a circuit or between two electrodes, conductors of electricity. Take a look at the picture on the left. Many of you may remember this experiment from school. This is where there are two wires that are separated by a small air gap and are connected to electricity at a controlled rate. The voltage is slowly increased until electrons from the positive side leap across the air gap to the negative side. Basically, as the electrons break free, they turn the air into plasma. And since plasma is a great conductor of electricity, the arc appears between the two wires. This creates a buzzing electric arc that slowly travels upward. This process produces light and heat. This example is in a controlled environment. However, in a real-world situation, electrical arcing can produce arc flash, where the electricity flows and discharges along an unintended path. These flashes ignite with the particles in the air in the environment, which can be anything from dust to gas. These arcs can exceed over 10,000 degrees Fahrenheit. So what is a welding arc? An electric arc used for welding is called the welding arc and is usually between a thin rod or wire and a base metal plate. In welding, this is an intended path, and the heat is used in a controlled manner to melt the metal to produce the weld. Now let's begin with a list of the welding machines, and listed generally in descending order with the amount of welding fumes that would be produced by these processes. Arc welding is where heat is added via electricity to melt the metal. In a flux core welder, the flux is inside the electrode. There is no shielding gas, and it produces the most amount of welding fumes. Next, there's stick welding. In this process of stick welding, the flux is outside the electrode. There is no shielding gas, and it produces the second most amount of welding fumes. Next, there is submerged arc welding. This is usually done on a flat surface because in this process, powdered flux is poured over the weld during the welding process. It produces the third most amount of welding fumes. Next on the list is MIG welding. In this process, shielding gas is needed. This can be used with flux core electrode or with a solid core electrode. It produces the fourth amount of welding fumes. Next on the list, TIG welding. In this process, tungsten is used as the electrode, and it is not consumed. This needs shielding gas and a filler metal. It produces the fifth most amount of welding fumes. Next on the list is plasma arc welding. The electrode is inside the welding nozzle tip and is surrounded by plasma gas. This is extremely hot, extremely loud, and extremely precise. Now let's move on to a little different type. This is oxyacetylene welding. This uses compressed gases to be used as the heat source. This uses oxygen and acetylene mixed together to produce the heat to create the weld. This will also use a separate filler metal that will be used if you're joining two pieces together. Oxyacetylene welding can also be used to simply cut the metal, which is often the case. Another type is resistance welding. This is where there's electrical resistance on opposite sides of the metal pieces that need to be joined together. This uses direct heat in a short time span and creates fewer welding fumes. Next on the list is solid state welding. This uses heat and pressure. This is used at temperatures below melting, and that creates fewer welding fumes. Another process for welding, a rather new process, is laser welding. Other processes that are similar to welding are brazing and soldering. So what is a health hazard? A health hazard is something that causes harm, sickness, or illness to vision, hearing, breathing, circulation, muscles and bones, skin, damages our body systems such as the immune system, reproductive system, or causes cancer or other diseases or targets specific organs. What are the type of health hazards for welders? The first one being air contaminants, which is what we're discussing today. These air contaminants are created from the high heat for melting the metals, the flux, and the shielding gas. This creates smoke, gases, and fumes. This process changes the structure of the solid metal into a metal fume, which is a metal in a vapor form while it is still hot. If the worker breathes in the metal fume while it's hot, it then cools when it is inside the lungs, nose, and throat. When the welding fumes are hot, they are in the air, but when they cool, they become dust and settle on work surfaces, clothing, and skin. Workers can later touch these surfaces and get the dust on their hands and transfer it onto their food, cigarettes, and things like that, and end up eating or breathing them in later on. We will discuss the details of cleaning up these contaminants later. Other health hazards that we will discuss in later webinars include heat, which is generated from the welding torch itself. The work site could also be in a hot environment. Excessive heat could lead to heat stress, including heat exhaustion and heat stroke. We will discuss the symptoms, treatments, and preventive actions later. Another health hazard is noise. Noise is created by the welder itself and the cutting and melting of the metals. Repeated and prolonged exposure to excessive noise could lead to hearing loss. We will discuss ocean noise regulations in another webinar. Light is produced from the welding process. This light is ultraviolet light. It can cause damage to the cornea of the eyes and damage to the skin. Another health hazard is ergonomic hazards. It is generally a repetitive body motion that causes strain on muscles, connective tissues, such as tendons, ligaments, and nerves. And these are the processes that allow us to perform those body movements in the first place. These injuries are called MSDs, or musculoskeletal disorders. There can also be a health hazard from radiation hazards. This can occur from some sideline activities where some welders could also be working. Although these are rare, I will show you some of the things that I've seen in the past that help you recognize and be aware of them. Another health hazard would be biological hazards. These can occur when an employee is cut or burned and blood or other body fluids leak out of the person and could expose other employees to it. Air contaminants from general welding will create moderately hazardous substances. These can be fumes, vapors, and smoke. So what's the difference? A fume is a metal that was a solid, has been heated beyond melting, and then has become an airborne particle. A vapor is a chemical that is airborne in the form of a gas, such as shielding gases, oxygen, acetylene, and things like that. A vapor can also be created from a chemical solvent, such as methylene chloride or other solvent that evaporates into the air when used in the workplace. A smoke is an airborne particle from something other than metal that is burned. This creates a visible suspension of carbon and other particles in the air, typically one emitted from a burning substance. We typically call something smoke when it looks like smoke. All welding processes emit fumes, whether it's MIG, TIG, stick, torch, laser, and/or plasma torch welding. The hazards of each are different. Many of the metals used in welding, such as steel and iron, may only present general hazards, such as metal fumes, gases, and smoke. In the general welding process, you might have antimony, aluminum, cobalt, iron, molybdenum, nickel, silver, tin, titanium, and/or vanadium are typically found in welding fumes. Each of these fumes have their own individual permissible exposure limit. Many of these fumes that are created from general welding processes are regulated by OSHA under 29 CFR 1910-1000 in the Z tables. These welding fumes can cause serious health problems for workers if inhaled. Short-term exposure can result in nausea, dizziness, or eye, nose, and throat irritation. Prolonged exposure to these fumes can lead to nervous system damage or kidney damage. We will discuss the potential health effects of several hazardous things that our welder could be exposed to on their jobs. Air contaminants from certain other welding processes can create more severe hazardous substances. Certain other metals used in these welding processes create a higher degree of concern because they could be more harmful to the worker's health. These metals include cadmium, beryllium, manganese, lead, hexchrome, which is another term for hexavalent chromium, also zinc, and arsenic. Other chemical solvents used in welding could contain methylene chloride or other petroleum-based solvents. There may also be other particles in the air in the welding environment, such as asbestos, that can be in the air where you might be welding. Many of the air contaminants that I will be discussing today are regulated under the OSHA expanded standards. Because of the higher degree of serious health complications and the uniqueness of the following requirements: the way the health hazards affect the body, there may be requirements for medical monitoring, there may be requirements for control methods specific to these metals, there may be special training requirements, there may be special personal protective equipment requirements, and other specific requirements for each metal. As you can see in this photo, asbestos could be found wrapped around pipes and tanks and boilers as an insulation to keep the water and other liquids inside them hot. It might be intact or it might be damaged. It might be broken off and lying on the floor. Your first thought should be, do not disturb. It might be in or near the area that needs to be repaired and welded. When asbestos material is damaged, it breaks off into tiny fibers that are too tiny to see. Breathing them into the lungs can cause or lead to asbestosis, mesothelioma, or lung cancer. The bottom line is do not disturb. Do not clean it up yourself. Do not remove it yourself. If you are working in an area with suspected asbestos, avoid accidentally bumping it or breaking it. If it needs to be removed in order to access the part that you need to weld, it should be done only by someone who is trained and equipped to remove it safely. Asbestos exposure could cause asbestosis, which is scarring inside the lungs. It could cause lung cancer, which is accelerated abnormal cell growth, or it could cause mesothelioma, which is a plaque growth in the lining of internal organs. OSHA has regulations on asbestos in the expanded standards because of the higher degree and serious health complications and the uniqueness of the following: the health hazards, how they affect the body. Management may have extra responsibilities when the exposure level exceeds the Pell or what is called an excursion limit. This will require initial air monitoring for an 8-hour full day work shift. This could also include requirements for exhaust ventilation. It may require wet method for the disturbance of the material. It may require containment of asbestos material. It may require the use of respirators and will require a respiratory protection program. It may require protective clothing, full coverage clothing. It may require medical surveillance of these employees. This is just a basic summary of the extra management responsibilities for these highly hazardous chemicals and particulates listed under OSHA's expanded standards. Asbestos is listed in the expanded standards 29 CFR 1910.1001. This standard applies to materials containing more than 1% asbestos. Asbestos in the air, the Pell is 0.1 fiber per cubic centimeter of air over an 8-hour time-weighted average, TWA. There is an excursion limit of 1 fiber count per cubic meter of air during a 30-minute sampling period. Another possible air contaminant could be beryllium. Beryllium can be found in some welding electrodes and some brazing rods. These can be in a combination of other metals mixed with beryllium. These other metals could be things like copper or bronze. Workers in industries where beryllium is present may be exposed to beryllium by inhaling or contacting beryllium dust on surfaces. Inhaling or contacting beryllium can cause immune response that results in an individual becoming sensitized to beryllium. Individuals with beryllium sensitization are at risk for developing a debilitating disease of the lungs called chronic beryllium disease if they inhale beryllium after that point of becoming sensitized. Beryllium-exposed workers may also develop other adverse health effects, such as acute beryllium disease and lung cancer. The OSHA regulations on beryllium are in the expanded standards under 29 CFR 1910.1024. This standard does not apply to materials that contain less than 0.1% beryllium by weight. The permissible exposure limit to beryllium is 0.2 micrograms per cubic meter of air, measured over an 8-hour time-weighted average. The action level, which is half of the Pell, is 0.1 micrograms per cubic meter of air. A short time exposure limit is 2.0 micrograms per cubic meter of air. This is over a 15-minute sampling period. In a workplace where beryllium is used, management could have extra responsibilities when the exposure level exceeds the Pell or the action level. There would be a requirement for exposure monitoring over an 8-hour full shift and a 15-minute short-term exposure. Dermal or skin contact with beryllium could be a hazard, and it would require cleaning surfaces of beryllium dust. There would be a requirement for marking off regulated beryllium work areas. It could require local exhaust ventilation. It could require respirators and a respiratory protection program. It may require protective clothing, full coverage. It could require medical surveillance of the employees. This is just a basic summary of the extra management responsibilities for these highly hazardous chemicals and particulates under the OSHA's expanded standards. Cadmium is another potential health hazard if it's used in some of the welding processes. Cadmium can be found in some welding electrodes and some brazing rods. This can be a combination of cadmium mixed with other metals such as copper or bronze. Occupational exposure to cadmium can lead to a variety of adverse health effects, including cancer. Acute inhalation exposure, which is a high level over a short period of time, to cadmium can result in flu-like symptoms, which include chills, fever, and muscle pain, and can damage the lungs. Chronic exposure, which is low-level exposure over an extended period of time, can result in kidney, bone, and lung disease. OSHA regulations to cadmium are in the expanded standards under 29 CFR 1910.1027. The Pell, or permissible exposure limit, is 5 micrograms per cubic meter of air over an 8-hour time-weighted average. The action level for cadmium is 2.5 micrograms per cubic meter of air. When cadmium is used in the workplace and could create these hazards, management would have extra responsibilities when the exposure level exceeds the Pell or the action level. This would include air exposure monitoring, marking off regulated cadmium work areas, could require local exhaust ventilation, could require respirators and a respiratory protection program. It could require protective clothing for the employees, which would be full coverage clothing. It could require cleaning the surfaces of cadmium dust. It could require medical surveillance of the employees. This is just a basic summary of the extra management responsibilities for these highly hazardous chemicals and particulates under the OSHA's expanded standards. Another health hazard that could be present in a work environment where welding is occurring is hexavalent chromium. This is also known as hex chrome. It could also be known as chrome 6. Chromium is part of stainless steel and other metal alloys. Industrial pipes and other connectors might be chrome-plated to prevent corrosion. Hexavalent chromium is one of the valence states, which is +6, of the element chromium. It is usually produced in an industrial process. Chrome-6 is known to cause cancer. In addition, it targets the respiratory system, kidneys, liver, skin, and eyes. Chromium metal can also be added to alloy steel to increase the hardenability and corrosion resistance. A major source of worker exposure to chrome-6 occurs during hot work, such as welding on stainless steel and other alloy steels that contain chromium metal. Chromium may also be used as pigments in dyes, paints, inks, and plastics. It can also be used as an anti-corrosive agent in electroplating chromium onto metal parts to provide a decorative or a protective coating. Who is exposed to hexachrome? Many workers in a variety of occupations are potentially exposed to chrome-6 in the United States. Workplace exposure mainly occurs in the following areas: welding and other types of hot work on stainless steel and other metals that contain chromium, in occupations where pigments, spray paints, and coatings are applied to metals, and in the worksite where they are operating chrome plating baths to chrome plate metal. Hexavalent chromium is in the OSHA regulations in the expanded standards under 29 CFR 1910.1026. The action level of the airborne chromium is 5 micrograms per cubic meter of air. The action level is 2.5 micrograms per cubic meter of air. And here again, we're seeing that with this potential for hexachrome being in the air, management has extra responsibilities when the exposure level exceeds the PEL. This would require exposure monitoring over an 8-hour full shift workday. They must ensure that the worker exposure levels are below the action level, or if not, then additional air monitoring would be required. Management is required to ensure that the employee exposure level is below the PEL, the permissible exposure level, or the following control methods may be required. They will require cleaning surfaces of hex chrome dust. They will require marking off regulated hex chrome work areas. It could require local exhaust ventilation, respirators, and respiratory protection program. It could require protective clothing, which would be full coverage clothing. It could also require washing facilities and change rooms so that the employees can get these welding fumes off of their body. It could also require medical surveillance of these employees. This is just a basic summary of extra management responsibilities for these highly hazardous chemicals and particulates listed in OSHA's expanded standards. Wait a minute. I see chromium listed on my multivitamins. How can it be bad for me? Well, in a multivitamin, it is chromium in a different form. It is a different structural arrangement. When extreme heat, such as welding, is added to hardened metal chrome, it changes it. Look at the wheels and tires on the two cars. The first car has normal round wheels, which gives you a smooth ride, no problem. This is an example of chrome 3, which would be in your multivitamins. However, changing the chromium through high heat changes it to chrome 6, and it becomes hexavalent chrome. This changes the way the chemically combines with other atoms in your body. To illustrate this, the second car has wheels that have 6 sides instead of round. Yeah, the picture has 8 sides on the car, but that was the best picture I could find. But this is just to represent that in driving this car with these top wheels, it will not give you a smooth ride. It will make it rough, bumpy, with a lot of vibrations. It will make you dizzy, shaky, and sick to your stomach, which just is a representation that hex chrome 6 is bad for your health. Another potential hazard where welding could be occurring would be lead. Lead can be found in industrial paint, such as on industrial pipes, bridges, cars, boats, etc. Lead can also be found in some soldering wire used for electronic device electrical connections. The two routes of entry for lead into the body are inhalation of dust or fumes containing lead and by ingestion or swallowing of lead containing materials. Lead is very toxic to the human body, and prolonged and repeated exposure causes damage to the nervous system, kidneys, blood, and is suspected of causing cancer. Lead regulations are found in OSHA's expanded standards under 29 CFR 1910.1025. The PEL for lead is 50 micrograms per cubic meter of air over an 8-hour time-weighted average. The action level for lead is 30 micrograms per cubic meter of air. And with lead, again, we're seeing that management has extra responsibilities when the exposure exceeds the PEL or the action level. This could require exposure monitoring for an 8-hour full shift workday. This would require that management ensure that the employee's exposure level is below the action level or additional air monitoring is required. Management must ensure the employee's exposure level is below the PEL, or that would require the following control measures. With the air sampling, the employer must notify each employee of the results of this testing. It would require cleaning of surfaces of lead dust. It would require local exhaust ventilation. It could require respirators and a respiratory protection program. It might require protective clothing, and it would require medical surveillance and biological blood testing of these employees. This is just a basic summary of the requirements for these highly hazardous chemicals. Another potential health hazard in an environment where this metal may be being used in the worksite is manganese. Manganese can be found in carbon steel and also used in steel alloys. Small amounts of manganese are added to steel to improve the workability of steel at high temperatures. Manganese is an essential nutrient. A healthy person with normal liver and kidney functions can excrete excess dietary manganese. However, inhaled manganese is of a greater concern because it bypasses the body's normal defense mechanisms. This can lead to manganese accumulation and adverse health effects, including damage to the lungs, liver, kidney, and central nervous system. Male workers exposed to manganese also have a higher risk of fertility problems. Prolonged exposure to high manganese concentrations in the air may lead to Parkinsonian syndrome, which is also known as manganism. OSHA regulations on manganese are found in 29 CFR 1910-1000. Manganese is not in the expanded standards. There is a regulation on manganese exposure, which is 5 milligrams per cubic meter of air. This permissible exposure limit is the ceiling limit, which means that the exposure shall not exceed this level at any time. There is no action level for manganese. Another health hazard that could potentially be in a work environment where welding is being done would be zinc. Zinc can be found as a coating material used to galvanize metal. The typical effect of breathing zinc fumes is metal fume fever. Welding on galvanized metal over a 1 or 2 hour time span without wearing the proper personal protective equipment, you may experience severe thirst, pain in the legs, shivering, congestion in the head, dryness and tickling of the throat, and a cough. In very bad cases, you may feel severe shaking, shivering, a high fever, buzzing in the ears, nausea, vomiting, and even hallucinations and convulsions. These symptoms could last up to 24 hours. Some of you may weld over a period of time and get used to these symptoms, and that you may have actually built up an immunity to hide the full effects. If you take a break from welding over the weekend or over a holiday, the symptoms will often come back the next time you weld on galvanized metal. Because of this behavior, metal fume fever is sometimes called Monday morning sickness. Ways to protect yourself when welding on galvanized metal. In all operations where metal fume is present, you should work in a well-ventilated area. The best way to protect yourself against metal fumes is to use local exhaust ventilation at the source of the smoke. Do not recirculate the air within the shop. If good local ventilation is not possible, you should wear an approved respirator, which will fit inside the welding mask. The respirator will collect the welding fume particles and keep them from entering your lungs. A paper dust mask may not be adequate. If you find white dust inside your welding mask, then you may not be properly protecting yourself from the fumes. After you have finished welding, wash your hands and face thoroughly with soap and water. Do not eat, drink, or smoke within areas contaminated with welding fumes. If you think you've been exposed or if you're experiencing symptoms of metal fume fever, report it to your supervisor. The OSHA regulations for zinc are found in 29 CFR 1910.1000. The PEL for zinc is 5 milligrams per cubic meter of air over an 8-hour time-weighted average. There is no action level. This is not in the expanded standards. Another possible health hazard in certain welding environments could be arsenic. When welding on aluminum, it may generate fumes that contain fluorine, arsenic, copper, silicon, and beryllium. Here we're talking about arsenic, and it can be harmful to the eyes, skin, liver, kidneys, lungs, and lymphatic system. Exposure to arsenic can also cause cancer. The regulations on arsenic are in the expanded standards under 29 CFR 1910.1018. The PEL for arsenic is 10 micrograms per cubic meter of air over an 8-hour time-weighted average. The action level is 5 micrograms per cubic meter of air. Again, since arsenic is in the expanded standards, management has extra responsibilities when the exposure level exceeds the PEL. It would require exposure monitoring for an 8-hour full shift workday. The employer should ensure that the employee's exposure levels are below the action level, or additional air monitoring is required. If the exposure level exceeds the PEL, then extra control measures may be required, such as cleaning surfaces of arsenic dust, marking off regulated arsenic work areas. It may require respirators and a respiratory protection program. It may require protective clothing, which would be full coverage clothing. And with that, may require washing facilities and change rooms so that the contaminated protective clothing remains at the work site and is not carried home by the workers. It could also require medical surveillance of these employees. There again, this is just a basic summary of these extra management responsibilities. Another air contaminant that could be present in a work site where welding occurs would be methylene chloride. Methylene chloride is in many, but not all, anti-spatter products. Methylene chloride is an eye irritant, a skin irritant, and is a carcinogen. Methylene chloride is in the expanded standards 29 CFR 1910.1052. The PEL is 25 parts per million over an 8-hour time-weighted average. The action level is 12.5 parts per million. And since methylene chloride is in the expanded standards, it requires extra responsibilities for management when the exposure level exceeds the PEL. It requires exposure monitoring of the employees for an 8-hour full shift workday. If the exposure level exceeds the action level, then additional air monitoring is required. If the exposure level exceeds the PEL, then additional control measures will be required. That could be cleaning surfaces of methylene chloride dust, marking off regulated methylene chloride work areas, may require local exhaust ventilation, may require respirators and a respiratory protection program, may require protective clothing, that's full coverage clothing, may require washing facilities and change rooms, and it may require medical surveillance of the employees. This is just a basic summary of these extra requirements. Now let's talk about locations of where the welding process is occurring. It could be occurring in what are known as confined spaces. What is a confined space? It's a space that is large enough to fit the entire human body to perform the work that needs to be done. This area would have limited or restricted means of entry or exit into the space. This space would not be designed for continuous human occupancy, and it has a potential to have a hazardous atmosphere, which would make it a PRCS, which is a permit required confined space. You can reclassify a space so that it's not a PRCS if you eliminate the hazards and you ventilate so that you stay below the Pell. In a confined space, many of the hazards can be intensified, such as air contaminants due to lack of airflow. It could intensify ergonomic concerns, which we will discuss in another webinar. It could increase noise, which we will discuss later. It will increase heat, which we will discuss in another webinar. In a confined space where welding is occurring, air contamination is of particular concern. Since the space is not designed for continuous human occupancy, it probably does not have doors or windows to open for natural ventilation, and there is probably no mechanical ventilation built into it. Confined spaces while welding means a relatively small or restricted space, such as tanks, boilers, pressure vessels, or a small compartment. They are spaces that are normally enclosed by solid walls and have no natural ventilation and have restricted means of entry and exit. You should always stay aware of gas emissions during larger breaks. For example, oxyacetylene cutters and hoses must be removed and or at least separated from the gas feed during these breaks. When welding in a confined space, the air quality is particularly important. Management must ensure that the entire space contains healthy, breathable air at all times. Although the confinement and spatial enclosure of the environment, natural ventilation in most cases is insufficient. Most of all, an oxygen content between 19.5% and 23.5% must be maintained while the employee is inside. One means of ventilating the space in a confined space is to use spot extraction. For example, through exhaust fans or hoods near the welding site, which are exhausted to outside of the confined space area. If spot extraction is not possible at all, then ventilating the entire space is an option. Companies should thereby select an air supply and exhaust solution to ensure a continuous flow of air. The supply and exhaust must be at different locations. If the proper ventilation is not possible, the welder must use appropriate breathing apparatus. The respiratory device, however, must be independent of the ambient air inside the space. Therefore, suitable breathing protection is not provided through a filtering and breathing device. Rather, exclusively self-contained respirator devices with hoses connected externally. Now let's talk about some of the controls used to prevent air quality hazards. In general, start with just preparedness for the control of any hazard in a workplace. Start with conducting a hazard assessment of your work site to know what hazards could be present. You can use the Hazard Communication Act of 29 CFR 1910.1200 for hazard communication. Through this, you can know what you're working with by using the HAZCOM SDS sheets, which shows what chemicals or metals or products you're using in the work site and would list what the potential hazards of each one would be. OSHA has what is known as a hierarchy of controls or priorities of these controls. It starts with the number one and most effective control measure, which would be in engineering controls, and the next effective would be administrative controls, and the last and the least effective and your last resort controls are through personal protective equipment, or PPE, such as respirators. Even higher than engineering controls, you can use methods such as shown in the triangle on the right, which shows that elimination of the hazardous product could be a way of controlling it by not having it there in the first place. Or if you've got a hazardous product you're using, you could substitute it for a less hazardous product, which might still have hazards of its own. And then beyond that, then you get into the engineering controls to isolate people from being exposed to the hazard. In many cases, that might be controls such as ventilation and things like that. Most of the air contaminants discussed here today are high priority hazards and are in the expanded standards. Most expanded standards require air monitoring by an industrial hygienist. If the results are above the Appel, then respirators might be required. If the respirators are required, then a respiratory protection program is required. For the control method used to reduce or eliminate air contaminants, we start with conducting the personal air monitoring of employees who are doing the welding. The results of these tests will let you know if the employee is overexposed to welding fumes or other chemicals that are used by the employee. If the exposure is above the Pell, then these control measures must be taken to reduce the employee's exposure. Certain metal fumes may require additional air monitoring and corrective controls if the exposure level is above the action level limit, which is half of the Pell. Examples of these control methods include the following. Always use natural ventilation outdoors and good ventilation indoors to blow welding fumes away from the employee. You might need to increase ventilation by adding local exhaust ventilation indoors, as close to the source as practical. Vent to the outside away from coworkers. The SDS datasheet for each metal and solvent might provide guidance for control methods to reduce exposure. Some could even be that they are for outdoor use only. As I had mentioned earlier, you could use substitution of the hazardous product to a less hazardous product. You could also use substitution for a less hazardous welding machine process or other process used for melting the metal. When these methods that I've discussed are not effective or not feasible, then they could result to respirators could be provided to the employees when needed. And then you must follow the regulations found in 29 CFR 1910.134, which requires a respiratory protection program. When welding with certain, especially hazardous materials, a powered air purifying respirator might be required. That is called a PAPR, or a PAPR. When welding within a confined space under certain conditions, airline respirators with an air supply hose might be required. In some of the control methods of air quality contamination, here are some pictures of what it would be like to do the personal air monitoring on the employees. In the picture on the left, it shows a typical setup for air monitoring of the employees in the workplace, where a small air pump is attached to the worker's belt. From that, a Tygon plastic tube runs up the person's chest or back over their shoulder, and at the end of the tubing, a small air filter is attached to collect the sample of the welding fumes that might be in the air, which will identify and represent the amount of fumes that a worker breathes during the typical workday. The picture on the right shows basically the same thing, except that the small filter is placed inside the welding mask and closer to the worker's breathing zone. Part of the ventilation process, the extraction process, are shown in these pictures of local ventilation. The welding fume exhaust hoods should be placed close enough to the welding arc to be effective, yet not so close as to disturb the shielding gases used or to obstruct the welder's line of vision. The optimal distance from the welding arc to the exhaust hood can be determined by placing the edge of the extractor hood approximately or diameter of the hood from the arc source. For example, when the portable extractor has a 10-inch wide hood opening, the sweet spot should be approximately 10 inches from the arc source, while being angled away from the welder. Slight adjustments may be needed, but 10 inches distance should be a good and effective starting point. The photo demonstrates the proper hood position that is both effective and non-obtrusive. In order to exhaust the fumes to outside the building, you can connect the exhaust hood vent to a collective universal exhaust ductwork system as seen in the last picture. Just general ventilation and natural ventilation is being used. You can use the exhaust fans, such as the one shown on the left, which might be used indoors, which uses a powerful extraction fan and ductwork, which could be led to outside the building. If you're welding outdoors, you would want to place yourself such that natural wind is coming from behind you so that the smoke welding fumes is blown away from the breathing zone of the employee. Part of the air contaminant control measures might be the use of respirators. Here are some respirator pictures. When other methods previously mentioned are not effective or not feasible, respirators could be provided and used by the employees when needed. This can be found under 29 CFR 1910.134. Respirators are generally somewhat bulky with the half-face mask and the filtering cartridges attached. See the picture on the top right. This type of respirator would not be compatible under a welding helmet. There are specialized respirators designed to fit under a welding helmet, if you see the picture on the bottom left. There are also specialized welding helmets with built-in respirators. When welding with certain especially hazardous metals, a powered air purifying respirator, PAPR, or PAPR, might be required. This apparatus is the picture in the bottom middle. When welding within a confined space under certain conditions, airline respirators with an air supply hose might be required. If you look at the picture on the bottom right, is an example of that. The air quality in a confined space is critical. You must start with evaluating the air and other hazards before going in. Depending on the situation, you might need to conduct air monitoring during the welding process inside the confined space. Gases such as helium, argon, and carbon dioxide displace oxygen in the air and can lead to suffocation. Particularly when welding in confined or enclosed spaces, carbon monoxide can form. This poses a serious asphyxiation hazard. If in the confined space, rusting or rust is occurring, or other decomposing biological material if that is inside the confined space, this can use up and deplete the amount of oxygen inside the space. In many cases in a confined space, mechanical ventilation is necessary in order to ensure that the air contaminants from welding are maintained below the permissible exposure limits. Respiratory protection may be required, and depending on the type of fumes being generated, the type of respirator could vary. In a confined space, there may be a requirement for an attendant to be present who remains outside the confined space and maintains contact with the worker who is inside the space. This is to ensure the safety of the worker in the event of an emergency and an emergency rescue is needed. Each work site and situation could vary. If an employer needs guidance, free OSHA consultative assistance is available from Kentucky OSH at the website consultative/KY Safe Training. There can also be other potential hazards inside a confined space, such as ergonomics and noise, which are intensified in a confined space, but we will discuss those in future webinars. You may visit some of our other training websites through KY Safe by going online and viewing these trainings at eTraining KY Safe Training. You can also view training webinars at KY Education and Training on the YouTube. Employers may request free consultative assistance, including air monitoring and noise monitoring, through consultative KY Safe Training. Thank you for attending the Welding Health Hazards and Controls webinar.